Hello, everybody. Welcome to another Tuesday on our Elastic User Group Live. This week, I'm your host again, Jay Miller, developer advocate for Elastic, and I am here to learn because, as many of my friends will tell you, I don't know anything about .NET. In fact, I am terrible when it comes to telling my friends about all the wonderful things about NuGet, and that's kind of it. That's all I know. But
That's
luckily
the .NET
for
words.
luckily for us, I've got Steve Gordon with me. Steve, how you doing?
Really good, thank you. Yeah, thanks for having me on.
Absolutely. Steve is a senior software engineer for Elastic, and he is the maintainer of the Elasticsearch.net client. And do we have you on some other projects too, or just that one you focusing?
That's the main one for now. I think there'll be some more .NET goodness coming along though, around sort of our ECS stuff as well, our ECS integrations.
Awesome. Well, take a moment, let people know a little bit more about yourself, let people know how you got to Elastic, and ultimately what you work on these days.
Sure. So I've been a software engineer on and off, I say, for at least 15 years. I've been working with .NET pretty much since .NET first became a thing. And I've always had a real interest in building applications with it. Prior to joining Elastic for the last kind of 5 or so years, I was kind of very heavily focused on building ASP.NET Core and microservices and all that kind of great stuff. Had the opportunity at the previous company I was working at to do a bunch of kind of greenfield development, which is always fun. So we were able to use the newest bits and pieces, and that kind of led on to blogging and speaking at conferences about those things, because some of the stuff we were sort of finding out as we went along was stuff that was very valuable to share with others in the community. So I've been blogging again 5 or 6 years at stevejgordon.co.uk about all of that kind of stuff, speaking about it. And in the last few years of that work, I worked quite heavily with Elasticsearch as part of the kind of the underlying infrastructure of one of the products that we were building, which was kind of an analytics and reporting tool. So got quite familiar with Elasticsearch.net, had some interactions with Martin, who works at Elastic as well, and it was the original sort of creator of the library. So we chatted on and off about sort of things I was working on around performance that tied into what he was doing. Finally met at a conference a few years ago in the Netherlands as well. And yeah, about a year or so ago, I suppose midway through last year, the opportunity came up to apply for the role to take over the maintaining of the client, which Martin sort of pinged over to me, and had a look, and it sounded really, really good fun. And after that, after a couple of rounds of interviewing and all of that stuff, I was able to join Elastic and pick that up.
So how much like using Elastic or using Elasticsearch and kind of the Elk stack or the Elastic stack were you using beforehand compared to like now?
So I must admit, I thought we were using quite a lot of its capabilities. You kind of, I think when you get into using a tool like Elasticsearch, it's very easy not to be fully aware of its huge capabilities. So we were using actually what turns out to be quite sort of, I suppose, a corner of what it was capable of. For some very common cases of sort of metrics and analytics, it's particularly good at. For log ingestion and sort of analysis, it's also very good. And those were kind of the areas we were using it with. But there were parts of Elasticsearch like the AML capabilities and some of the new stuff around data streams, which I hadn't really looked at. So now that I've joined Elastic and I'm starting to look at what the library is doing and how it's interacting with those APIs, definitely a lot to learn. And it's been really interesting kind of thinking with the knowledge I have now, how I'd go back and kind of re-engineer some of what we were doing. In terms of if I was still at that previous company, there's a lot of good stuff, particularly in the last kind of couple of major releases that's really brought it on as a product.
So I haven't used half of that stuff, so I might have to bring you on later to show me all of that stuff. But you know, what is it about .NET that kind of keeps you in that ecosystem, that keeps you there?
I've always, I think it's for me, it's been a progression of the languages and the learning curve. I sort of describe myself as a community taught, self-taught developer. Didn't study it formally at university or anything like that. And so one of the tools I picked up when I was first getting started was QBasic or QuickBasic at the time, which was a sort of fairly simple sort of programming language that I learned to get to grips with. And I moved that knowledge over onto Visual Basic at the time, which kind of got me into what became the .NET track. That was VB6 at the time. Did some ASP.NET stuff as that came out, and then slowly transitioned over to C# as the language of choice. VB is still a good language; it's still there, but once I made the switch to C#, I've not looked back from that, and I've just always enjoyed the community. We have some really interesting people. I know, a good 90% of the .NET sort of world is probably developers that aren't on social media and aren't necessarily faces you interact with daily, but there's a really good community in that sort of 10% that are visible on Twitter and streaming and sort of talking at conferences and things like that are putting some really interesting things out. And I think, honestly, if Microsoft hadn't done the work that they've done around what's become kind of the new .NET, so .NET Core over the last few years, which has gone into .NET 5 and soon .NET 6. If Microsoft hadn't done that sort of reimagining of the framework, maybe I would have looked at elsewhere. But with those changes, with that moving open source and being much more sort of community driven in terms of you can kind of get in and ask issue or raise issues and give your opinions on things, it's meant that it's, for me at least, it's been a nice community to be involved with, and I hope it sort of continues for a very long time.
Nice. I got two more questions, and after that, I'll let you show us what you got. Cool. You've been at Elastic little bit shorter than I have. I remember we started around the same time. What's been your favorite part about working at Elastic and working on this project?
I think I'm going to say the kind of the engineering culture as a whole. I was very happy in the previous role I was in, so it's one of those things like, am I jumping out something I'm really enjoying doing with a good team of people into a company that I think is going to be great, but maybe it doesn't turn out that way, and it definitely hasn't been the case, which is great. So the engineering culture, the mentality of people, we're mostly distributed, particularly with COVID, but as a whole, the company is well developed and well set up to be a distributed company, and I think that means that everyone's very open with one another. They're very clear. Communication is great, and it's really interesting to see how the wider Elasticsearch team and the whole Stack team think about our products from a really sort of passionate point of view. There's very deep conversations if you start going through the GitHub issues and the some of it's internal, some of it's public conversations about how things should work and how they can be improved. There is a sort of continual drive to making things better. So I'm kind of looking forward to hopefully doing some of the same on the .NET side of things. The client has been around for about 10 years now. It's a stable client, but there are opportunities to kind of move it forward, both in terms of how we maintain it and kind of keep pace with what's going on in the underlying Elasticsearch, and then also kind of how we take advantage of like new .NET-isms. So performance, sort of performance tuning it, making it work faster, making it work with newer API surfaces that are sort of becoming available in .NET, and sort of taking it forward. So hopefully a fresh pair of eyes gives me the opportunity to kind of look at some of those areas sort of afresh and with a critical eye, and hopefully take some of those ideas forward where they make sense.
Awesome. And before I ask this last question, I want to remind everybody this is a work with me and an AMA. So if you have questions, feel free to ask them. I'm mostly just emceeing. I'm going to let Steve take over in just a second. But if you have some questions about, Steve's career path, what it's like to be at Elastic, or anything that he's showing us on screen, feel free to just throw it in the comments as well. And of course, if you've got some, a question that may not be relevant to this stream, but is something that we can definitely help with or cover, we do have a community over at discuss.elastic.co. There's thousands of people in there answering questions, being super helpful. Some of them even Elastic employees. So like we get to go in and hang out as well and see what people are talking about. But my last question for you, Steve, before we jump into this is, we talked about what it's like to work at Elastic and like the team at Elastic, but what about the community around Elastic? What's been your experience working with them and getting to know them better?
Yeah, it's definitely an area that I want to try and discover how big that community is out there. The Venn diagram of people that are in that public sort of .NET community that are also using Elasticsearch, and there's a few people that I know already from sort of speaking at events and sort of past interactions that I know are using Elasticsearch that I've been kind of chatting to. And honestly, the feedback I'm wanting and I'm looking for is honest criticisms of what it could do better or where it doesn't work. We've had so I've talked to some people that are sort of well known about sort of dealing with performance in .NET who've got some suggestions. I've had some critical opinions from people about how they found the API to get started, and that's all really useful information to help us kind of make it better. Do we need more documentation? Do we need more video content sessions like this where we can start to explain how we see it working and also how we can guide changes to the client going forward. But certainly the interactions so far have been great, and I welcome anyone to sort of reach out. My DMs are open on Twitter. It's probably the easiest kind of general way to reach out to me. So I'm at Steve J. Gordon there. And if you have questions or you want to share some feedback, or you're about to engage on a sort of a .NET project that uses Elasticsearch and you want to kind of either feel out some ideas or just share with me an experience as you've kind of started with it. Those are the things I'm really looking to kind of try and get from people that are watching these kind of sessions, if possible.
Awesome. Well, that said, I'm ready to learn. So I'm gonna let you take over and just, I guess, get to me knowing a little bit more about .NET and Elasticsearch, other than, again, NuGet. I know that part. Config files. I see Jamie in the chat as well. He showed me a thing or two about config files, but that's really about it. So you've got a hard challenge ahead of you. But with that, take it away.
Absolutely, sounds fun. Well, I thought the since this is our first stream, I thought what I'd do is kind of do file new project. And we can obviously go a bit deeper and a bit sort of more advanced in the future if people have specific areas they want to dive into. There may well be bits of the .NET client I've never used from a client perspective, and I may be sort of not hitting those areas of the code just yet in what I'm doing. So I'm hoping to learn some stuff as we go as well. But I thought it'd be really fun to break all traditions of streaming and actually use like very early preview products in a live stream, because that can never go wrong. So I've actually got Visual Studio 2022, which is the new hotness. It's going to be, well, it is a 64-bit application, so it can gobble all of the memory on this PC. And I thought we'd play around with just kind of putting some data together in Elasticsearch, doing some querying, and then we can kind of see where we go, really. It's pretty free form based on any questions you have or the others have. So going to just start straight away. The only stuff I've pre-prepared here is I've used the sample data that I'm going to use in a couple of previous live streams. So I've got a bit of an idea about sort of how to structure working with it. But I wanted to really start from scratch just so we can see what's going on. So I'm going to actually create a console app for the purposes of today. It's kind of the quickest kind of .NET project template to work with. It doesn't have too much baggage. And you can see already my choice of choosing 2022 might be a bit of a problem. Oh, there we go. It's woken up. So we'll call this console app 6 because you can think of good naming. And well, it looks like I'm going to have to be preview of .NET 6 as well. So it's going to be all of the latest and greatest bits from Microsoft. For those that are kind of following along and perhaps aren't aware, Microsoft have kind of moved to a yearly release cycle now for .NET. So in the early days of .NET Core, so 1 to sort of 3.1, we had quite frequent releases, and we had this kind of. It was good because a lot of stuff was coming out very fast, but it was also kind of bad as a developer to keep up. And I know a lot of people struggled with that. I think the move to yearly releases is hopefully going to be better for the community. People can kind of see what Microsoft are working on, and they're doing, as they're doing here, they're doing preview releases kind of 4 to 5 months, I guess, before they plan to release in November. And those are kind of coming out each month. I say 4 to 5 months. It's probably been more because they're every month and we're on preview 6 already. So there's quite a few. So we're in a kind of file new project console app here. And what we're going to do is I'll show you the actual data that we're going to work with. On my local file system, I've got this CSV file, which is a download of some real world stock data. And all it is a fairly simple CSV file. So this is, I think, the Fortune 500 at the time companies for 5 years worth of daily data. So for each company, for each day, we have a row. So in this case, the stock symbol AAL for this date, and we can see the open, high, low, close amounts of their trading in those dates. So depending on what you're doing in your sort of .NET space, a lot of people sort of ask how to work with sort of Elasticsearch from a more broad question of, should it be a primary data store? Should it be a supplementary data store? Should it be a search engine? It can kind of be what you need it to be. Ultimately, you need to make some decisions up front about how resilient your data needs to be, what type of querying loads you're going to have on it. For metrics and logs, often Elasticsearch can be the kind of the source of truth and the data store. For other systems, you may sync data from relational databases and store parts of that in Elasticsearch so that you can do full text searching over it. It's kind of up to you, and how you get the data in will be up to you as well. And so one of the sources could be that you get a feed of data over a message queue or something. In this case, I'm going to load it from this file just because I don't want too many moving parts. But this could quite easily be data that's streaming in over a sort of message queue that we're just polling or pulling from and then periodically indexing. But let's imagine we have this file with all 20-something thousand rows of data in there, and we want to ingest all of that into Elasticsearch. So I'm going to do this all from .NET just to show that it can be done. And the first thing I'm going to do is I'm going to add and Jay, you'll be good, you're happy with this, a NuGet package. So we're going to go to NuGet straight off.
Yes.
the piece you know about, so that's a good start. And then once this loads, I'm just going to search for Nest in this case. So just quickly to explain how the packages look today, at least in the 7.x world, we have Nest, which is what we describe as our strongly typed sort of high level client. And by this, we mean we have a mapping for pretty much all of the request and response objects that Elasticsearch may send and receive in its REST API defined as C# objects. And then we have a client layer that allows you to interact with those API endpoints through the client without having to know what URLs they live on and those kind of things. And a couple of different syntaxes for how you might construct requests and responses. And we can kind of maybe dig into that if there's time as we're going through. This is, for, I guess, 99% of the viewers, the package you probably want. It's easiest to work with in the sense that you have those models. But it does sit on top of this second package here, Elasticsearch.net, which is what we describe as our low level. And so this is kind of the layer that deals with the HTTP transport, handling things like failover. If one of the nodes in the pool of nodes that you have isn't responding, try another node, that kind of thing. And it has the details about the API endpoints that exist in Elasticsearch.
I have a question for you about that, Steve.
Sure.
So in the most of the client work that I or not client work, but I guess the clients like Elasticsearch clients that I've done, I tend to always want to go low level. I don't know why. Maybe in Python it's like a different thing. But what what are the big benefits of choosing Nest over kind of the lower level areas?
So the main thing is that you don't need to spend time thinking about what is the object I need to create in C# that can represent a search request, for example. Search requests initially can be quite simple, and then as you start layering in aggregations and building out fairly complex queries that you might want to perform, that kind of work is a little bit more difficult if you want to, write an object to represent that yourself, serialize it to JSON, send it over through the low-level client, and then handle deserializing the response back into something that you can work with in your code. The cases where you might want to drop to low level, and it's probably easier looking at it from that view, is where you have extremely high performance needs, or you want to do some kind of customization on that serialization that's quite extreme. So you maybe only want to read parts of the response, and you're not interested in a full object that represents the whole load of data. So places we see that being used is maybe in some of the third-party integrations with things like Serialog, that allows Serialog to stream log data out to Elasticsearch through .NET. Those would probably want to use the low level because they want to be in fine control of optimizing the bytes that are being allocated over the lifetime of your application. But as I say, for most people, you probably want the object models, and maybe if we get into the code in a moment, we'll see why that's useful, I guess. So I'm going to choose the latest stable version of the client. Typically, you always want the latest version of 7x. So even if you're talking to a 7.2 Elastic cluster, you should be using the 7.13 client. We're backwards compatible within the same major version. So this is tested as part of our CI process against all of those previous 7.x versions. And basically what it means is you're getting the latest functionality, but also all of the latest kind of improvements, enhancements, bug fixes, that kind of thing. So sometimes that comes up as a question, do I have to be on 7.2 of Nest because I'm using 7.2 of Elasticsearch? No, you don't. Always grab the latest 7 version if you've got a 7 cluster of any number. And if for any reason you happen to be talking to an older cluster and something doesn't work the way you expect with a newer client, please do open an issue for that. We'll take a look at it. As I say, we run all of our extensive integration tests that we have against each of those different cluster versions before we build a package with the intent of making sure we catch that kind of stuff. So I've introduced the package now into my application. So we're going to do a couple of things. So the first thing we'll do is, let's imagine this is something we want to run, essentially like a sort of little utility to start loading in a set of data. So we'll want to know, if the cluster doesn't have an index for the data, maybe it should create one, and then we should put the data in. But if the index already exists, perhaps we don't want to do that. So let's imagine we'll create a const string. We'll call this index name, and we can name the index whatever we want. I'm going to call mine v1 of stock demo. And I'm also going to define a string for an alias. Now we don't have to get too deep into this for a beginner level thing, but what I've learned to do, I think, as working with Elasticsearch over the years, is it's always a good idea to create your index and then access it through an alias. What this means is, if in the future you need to change how your data is indexed and essentially, how you store the data for different search requirements you may have, you can potentially change the underlying index that alias points to without updating client code. So in this case, we are actually going to create the raw index as well. But in a kind of receiving application, you generally always kind of query through this alias name, and you don't need to care about whether this is v1 or v2 of the index under the hood. And it's always good to do that up front, in my opinion, because then you don't have issues in the future when you suddenly realize, oh, we've changed the name of this index because we've changed how we've structured our data, and now we have to update all the consuming applications. So not a requirement, but something I found relatively helpful. I'm going to create an Elastic client autocomplete's a bit funny in Visual Studio 2022 by the looks of it. There we go. We want the nest namespace here, and we create a new client. So what have we achieved here? So now we have a client through which we can communicate with Elasticsearch, and I've not provided much in the way of configuration here. In fact, I've provided 0 configuration. So what will happen by default in our client is that we'll assume, okay, well, you haven't given us any other information to go on. So we'll assume that you probably want to talk to Elasticsearch running on localhost on port 9200. So the default port on localhost. And it just so happens that on this PC, I've got this, let's show you here, this Docker Compose file that I've used for development. And this is now running already on my PC. So I've basically specified that Docker locally is going to run a single node Elasticsearch cluster of the latest, well, not quite the latest, but nearly the latest version. I think there's a 13.2 out now on 9200, exposed to my machine on 9200, and a Kibana instance on 5601. And I can validate that if I can find the right window here. I've got just a browser open here, and yeah, it's still working. It seems to think it's French, but it's not. And this is now just hitting that localhost 9200 endpoint. So for getting started, there's kind of 2 ways I like to do it. To be honest, my preferred way today is to spin up a cloud deployment in Elastic Cloud. I find that really convenient. It doesn't take up resources on my machine, and it's very easy to interact with that through our client. But sometimes, sometimes for small testing, particularly if you don't want network latency coming into what you're doing for prototyping, then you can also spin this up in Docker as we've done here. So what this means is this default configuration that we kind of infer by default with this new Elastic client, it will try and talk to that instance that's running on localhost there. So one of the things we can do is see if the cluster that we're talking to has an index of this name already, because if it does, we probably don't necessarily want to try and create it and seed it with data again. So what we can do is we'll get an exist response. We want to await client. I love this new IntelliSense, AI-driven IntelliSense in Visual Studio 2022. So it's already, actually, I'm not entirely sure how it's inferred some of this stuff, but it's pretty good. So I'm going to actually go into the indices kind of sub namespace, because we're working with an index. What we want to do is see if it exists, and we can just do exist async and autocomplete. I should have let that do that actually. And we're going to ask, does this exist? Now we've got some squigglies here because I've used await in a void returning method. So fortunately, CSharp 6 something, I think, introduced async main support. So now we can just make this an async task returning. So another thing that comes up, particularly with new users to .NET, is should we be using these async suffixed methods, or should we be using the non-async methods? Which
you read my mind.
I hear it so often that it's very common. The general rule, not just with our client, but with the .NET, is you generally want to be using the async APIs if they're available. And the common practice, particularly for libraries, is that where they're available, they will have the same name as the synchronous version of the method, but they will have the async suffix on there. And modern versions of things like JetBrains ReSharper, and I think probably Visual Studio as well, will recommend to you that you should use the, let's even see, let's go off-piste and see if Visual Studio, no, sadly, Visual Studio on its own doesn't seem to have the analyzer enabled. Perhaps it does. No, it doesn't. So I think there is an analyzer for it that you can turn on that will give you the kind of squiggly that will give you a recommendation that you probably want to use the async version. What this means is, because we're doing I/O here, so we're talking to Elasticsearch over a network connection, that's not going to immediately come back necessarily. It will be, some number of milliseconds usually for a response to come in. But by going with asynchronous code, we avoid tying up threads in our application. So these are the threads that are executing code. We avoid them sort of sitting there waiting around doing nothing while they wait for a response back. So in this scenario, the asynchronous path means, go and do this thing and notify me when it's done. And C# and other languages are starting to introduce this, I know, use the await and async keywords here to kind of make it very easy to write what looks like fairly procedural code. We don't have to think about wiring up complex callbacks when this method does return. Behind the scenes, the C# compiler can produce code that makes sure that anything after this await will continue when that piece of work is done without us having to think too much about it. In this case, we know that this exists response has been returned from the server. And you can see it is actually a strong type here, exists response. Let's see how good Visual Studio is at decompiling our code. So you can see, in this case, it's actually a pretty simple endpoint, because all we're basically asking is, does this index exist or not? And Elasticsearch will return us to 200 to the request if it is, and 404 not found if it isn't. But this is where the power of Nest starts to come in, and we can look at maybe a more complex example later. But these are the things that if you were doing this yourself, you would have to think about how you modeled this in your own code, and how you handle these situations. How do we check for this particular endpoint? Okay, we need to check the status code and we need to infer success from that. So that's the kind of thing that the client kind of gives you. So now we have the exist response. We can say, well, if not exists response dot exists, we could do a bunch of work, and we can, in this case, what we probably want to do is create the index and then put some data into it. So I'm going to do a new index response. You can name these as you see fit. I like to be relatively verbose. It's amazing. The autocomplete for a second there had exactly the method I wanted, but for some reason decided something else might be better. So we can do create async. And in this case, it's the we want to create one with the index name. So this says to Elasticsearch, create this index with this name. Now, for most applications during sort of early development, this might be fine. But how does it determine what the mapping will be for that index? So for those that are new to Elasticsearch, the idea of mappings in Elasticsearch is basically, how do we want the data that's going to be saved to this index, how do we want to store it for the search requirements we may have? And by default, Elasticsearch will basically take any blob of JSON you give it when you try and index a document. Any blob of JSON will be fine, and it will infer from that JSON appropriate mappings in a very generalized form. So if it sees a number, then it can infer that probably should be indexed in some kind of number format. If it sees something that's a string but looks like a date, it may make that as a sort of datetime type field in Elasticsearch. So it can do quite a lot of stuff for you kind of auto-magically. But often, as you get a bit more familiar, particularly with your query requirements, you might want to get a little bit more specific about how you want that data to be mapped for future search requirements. So what we allow on the Nest client is we allow two syntaxes for defining how we want to work with things. And in this case, I'm going to use our Fluent syntax. So let's create a block of code here. So this, I think, what is that? So it's just saying, yeah, that's fine. It's unhappy because I haven't actually done anything yet. So in this particular overload, what we've got here is this thing here called, and it's quite hard to see, I imagine, on the stream, but it's a thunk taking a create index descriptor. Now, don't worry about the complexity of all these words. These are are things that are a little bit, unfortunately, complex to parse for people new to .NET, but you don't have to think about the underlying sort of implementation detail too much of this. But what it basically gives is what we call this kind of fluent syntax that we can express how we want to define our mapping. And if you don't like the syntax, there is another way of doing this kind of thing. But in this case, what we're going to say is, well, I actually want to map some data. We can then define another sort of Lambda expression here that says, okay, how do we want to map our data? So in this case, what we want to do is map the data based on the type that we're going to be storing. Because we're working in .NET, we're probably going to have a type that represents the data we want to index, which currently we don't. So perhaps what we should do is define a type. And I'm just going to start with a very simple class. We'll call it stock data. And just to save a bit of time, if I can find it, I know I've worked with this same demo set in the past. So I'm just going to copy and paste. I'll do most of this fresh, but I'm going to copy and paste this block of code just to save a bit of time, because this is really boring kind of mapping code. And I'll quickly step through what I've pasted in here. So let's worry about that later and that later. The main thing on here is we have some properties. So these are strong representation of the data that is in that CSV file. So each row, you'll recall in the CSV file had a date, and then it had the open value, the close value, etc. And so this is just a fairly simple C# object that will allow us to kind of create an object that has that data set.
Hey, Steve, one of the things that I've been thinking about a lot more in terms of, and this is more of a comment than a question. One of the things I've been thinking about a lot more with some of the newer features, especially like runtime fields, is like whether or not I actually need a format in what I would expect. And I say that more as, sometimes you think it's like, oh, strings are fine. Like, we'll just do the strings. But then, if you try to do some math in a runtime field later on, then you wind up, breaking your neck trying to get that string back into its native format, or doing a little bit of the work beforehand. Is that something that you can easily do to modify this? And I say that as in, if you've got some data and you kind of need to, I guess, massage it a little bit before you start looking at getting it indexed. Is that something that you can do here with this, the way that you've set it up?
Certainly you could do. So in this case, the model represents my current understanding of the data set that I have. And as you say, those things can very easily through the life of a project evolve a bit, particularly from the perspective of querying it. Quite often you can just, you'll go through requirements gathering for your new system. You'll be told it really needs to do this kind of search capability, and you'll be great. I build that, and then days later there'll be a manager somewhere that will say, "Oh, but I can't search this way," and suddenly you'll realize that perhaps you wanted to have indexed that data differently. And that's one of the reasons why I kind of advocate putting an alias over data, so that you can potentially re-index data in the background if you need to. From a .NET perspective, this is pretty fixed to the data structures that I know I'm going to be getting from the CSV file. I could arguably have chosen different sort of numeric types, so ints and things for these values. I just happen to have already explored the file to know that probably a double, so they have some decimal point precision, is relevant there. This is our model kind of in the .NET world, and the mapping that we're about to create is kind of then going to control how Elasticsearch takes this data. And as you say, runtime fields is something I do recommend people look at that are working on new projects, because it's quite an exciting way to say, well, actually, when you're first building your project, maybe we don't want to worry too much about mapping stuff in any particular way. We just want to, most of the time, let the defaults store the data. And then as we start to work out what we need to query on that data, we can define these runtime fields, which actually execute across your data, can be at search time or can be at index time. But these runtime fields can kind of allow you to dynamically script how you access some of that data until you understand what your kind of access patterns are. And then in the future, you could potentially re-index that data more efficiently once you've got a slightly better picture of what the final use case is. So I when I've been learning about runtime fields off of some of the team internally, that seems to be a really good example use case for where you might want to use them, and then later switch to more traditional fields. Although I believe the performance is so good in many cases, runtime fields might be a good way forward for many application requirements.
And I think one of the things, even with this data set, if you're looking at like what was the cost at open, what was the cost at close, and then the highs and lows, like you could add runtime fields here for, what was the delta? What was the change in between from open to close? What was the highest what was the highest jump between high and low, and kind of all of those different things. So it is a nice way to say, I have some pretty basic data. Let me go in and then make that data like a little bit more dynamic without having to re-index everything again and again. And that tends to be kind of the struggle that I've had.
Exactly. Yeah. And that's a great point, because, we could get fancy here and try and sort of preempt those requirements by going, well, maybe we do need a property here that will be a calculated property, high minus low, to give us that difference. And then we index that directly in. And if we've done that, we've kind of tied ourselves into how that data's going to be stored in another field, potentially in Elasticsearch, that might not work for all scenarios, or we may want that, we may not want it as a numerical difference. We may want a percentage increase or something like that. And so, by kind of going with the kind of barest form of the data to begin with, looking at runtime fields for those requirements as they come up, and then later, as I say, you can easily go in and convert those runtime fields to regular fields potentially, and change the underlying data once you've understood those requirements. What is it that the business really does need from you? So we have our properties. I have a helper constructor here that is going to take a line of data from the file. So imagine we'll read this file line by line. And this just does some, it's not optimized code. This is not production ready code. It allocates everywhere. But essentially what I'm doing is trusting that the file is valid. And I know it is from testing. But this would not always be the case. But I'm just going to do a really simple split the line on commas. And then I know the index position of each piece of data. So I know, position 0, before the first comma, there will be a date. And then I can use .NET's kind of parsing methods here to actually try and parse the string value from that split operation into a .NET datetime type, and then push that in. The other thing I'm doing finally down the end here is this little company lookup, and this is just to give us some data, because this data set is more analytical than it is kind of full text search requirements. I thought it would be useful to have some data that would be kind of text we might want to do full text search on in the future. So all I've done there is, excuse me, alarms going off despite switching them off. What I want to do is just say, well, the lookup here says if you see the symbol MSFT, that's the Microsoft Corporation, and we'll actually put the full descriptive name into our data as well. And there's many ways you could skin this and do it. You might want to look at sort of ingest pipelines for this kind of work. I'm doing it all in .NET because it's, I'm a .NET developer. You give me the problem, that's where I'm comfortable. But again, a sort of learning experience, I think, of coming into Elastic is there is a lot of good stuff already been figured out for you in Elasticsearch and the related products. So, you might be tempted to do this kind of method for enriching your data, but perhaps actually if you looked at an ingest pipeline and set some stuff up there, you may have a different way of going about it. And you could just have an index that contains these mappings, and then do this at ingest time as well. So many different choices. I've done it here for simplicity. And ultimately, we now have a type that represents our data in the file. So now what I can do is I can call AutoMap, which is a Nest client concept rather than an Elasticsearch specific one, that basically will infer for us the mappings that we should use based on the .NET types. So it doesn't understand everything. If there's a complex type in here that AutoMap doesn't know about, it won't necessarily know what to do with it. But for these regular types like a date time or a double or a string, which we've got down here, it can basically say, well, when it's a string, we're going to assume that the mapping for that should be a multi-field of text and keyword, which is what Elasticsearch would do by default. And then for numbers, we want this as a sort of a numerical field, and we want date times as a date time type field. So that's a kind of useful starting point, but obviously it's only as clever as in terms of we know what the .NET type is. So I'm going to give it a little bit additional configuration here, and I'm going to say what I want to do is define certain properties on here, and we can do. So here I'm going to say I want to define a keyword property. Its name. Well, the name for the keyword is actually going to come from the model, so it's actually this, I saw on the chat. There's definitely with this syntax, this fluent syntax, it will be sort of lambdas all the way down. I'm going to make this. I'm going to make this generic actually, so that this should give us strongly typed helpers now. So these are the actual properties on our stock data type. And what I want to say is for the symbol property, index that as a keyword. And the only problem now is I've just got to get the right number of braces and brackets. There we go. The symbol field by default, as I say, would be indexed as text and a keyword, which is a kind of multi-field type. That means in Elasticsearch, we can do full text search across it, but we can also do kind of aggregations across it. I just realized why that's unhappy up there. Excuse me. Just tidy up the code as I go. It's because I've got to that. And there we go. I'm just going to clean up that syntax a little bit to make the compiler happy. So for symbol, we probably, this is just like, you know, those symbols that we had down here. So MSFT, ME. I'm unlikely to want to do full text searches across those. I'm probably only ever going to do exact matching for aggregation and filtering kind of operations. And so I can kind of pre-optimize my data mapping that says, for this, map it as just a keyword. And so that's a mechanism that you have for defining your mappings in advance if you want to do that in .NET. May very well be that you're already using sort of index templates and other functionality in Elasticsearch, and actually just by having an index name that has a certain prefix, it will pick up a predefined template. Again, you can do everything in .NET. Some of it might be easier and more sort of scalable as you evolve your projects to do directly in Elasticsearch with its capabilities, and then that limits the amount of manual code that we maybe need to write here. So the next thing we're going to need to do is we're going to need to be able to actually index some data. So the first thing we need to do is we need to be able to read the data out of our file. So I'm going to do this with a, I'm just going to create an enumerable of stock data. Turning method here, we'll call this read stock data or something like that. And we're going to do file. So we're going to do a stream reader here in .NET to open the file. It's going to need system.io, and I can give it the path, which I know in my case is C stock data, and then I just need to remember the name of the actual file. Stock data .csv.
I think we had a comment in the chat that says you may have a leading space in the American Airlines group.
I do. Well spotted, internet world. It's this is the advantage of having the sort of identifiers on for spaces and white space in Visual Studio, as long as I pay attention to them. So yeah, thank you for spotting that. So then I'm going to do a loop. Again, various ways of doing this. I'm just going to do a while line equals file.readline. Autocomplete is pretty nifty here. Is not null. Again, different syntax choices. .NET, C#, we can kind of You could express it now with these kind of is not kind of keywords if you prefer, or as the autocomplete was trying to do, we can use kind of more traditional kind of not equals null, or however you prefer to do that. We're all friends here. And then I'm going to, in this case, I'm making a sort of a enumerable. So wow, it's pretty much completed that. Cool. The autocomplete magic here is impressing me. I haven't used Visual Studio 2022 that much, and it's pretty much coding this for me, which is pretty cool. So in this case, what we're doing is this is now enumerable. So this is something that a consumer can kind of access to get a stream of values, in this case, stock data values. And so in this case, every time they sort of call next, essentially on this enumerable object, they will get given the next stock data line, and we're constructing that through that constructor that took the line from the file, so that read the whole individual line from the file, passed it into stock data, that did our conversion magic down here to give us our values for the properties. And so we can kind of access that. So for example, we could do something like for each var data in read stock data as an example, and then I could index the item. So this would be a very basic way that we could put the data into Elasticsearch. And basically what we'd be doing is we'd be indexing each line individually, so one index request at a time for every line in the file. And that would work. The reason we might not want to do that is if you think about the efficiencies, each line of data is a small blob of JSON, and each of those requires a full kind of HTTP request if we were indexing them individually. And the downsides with that is obviously, we're consuming time creating those requests, firing them, waiting for the response, et cetera, et cetera. So one of the things we have in Nest and in a lot of the language clients, so even if you're not a .NET dev and you're maybe in the Go client or you're in the Python client, we have helpers. And these are, we basically describe these as a kind of an API you can call in the client that doesn't necessarily directly map to an endpoint, but it might actually call multiple endpoints on your behalf, or it might do repeated activities and make it easy for you. And probably rather than me rambling, the easiest way to show that is to actually do it. So rather than doing it line by line, we might want to use Elasticsearch's bulk capabilities. So this is where we can say, here's more than one document in one single payload that we would like you to index, please. And again, this is something you could do directly through the client. So we could call, where is bulk? Yeah, there, right on the root. So bulk is, we can call client.bulk, and we could give it a bulk request. And we'd have to build that bulk request, adding in each of the stock data items we want. And we could say do 100 items at once. But now we have to think about how we build the bulk request, and we have to think about what happens in retry scenarios. So if one of the documents doesn't work, but the 99 of them did successfully index, what do we do? How do we want that to work? And that's all the kind of stuff you'd have to think about if you were using the API directly. But what we can do instead, so I'm going to do mistype everything, and I'm just going to call this bulk all. I'm going to call client.bulk all. And so this is one of our helpers. And basically, this allows us to, on your behalf, simplify the idea of indexing some data. So if you have any enumerable of data, you can pass it into this bulk all helper, and we'll index it. Now, the request needs a little bit of information. And again, I'm going to do this using lambdas. So I'm going to say the index that I want you to index into is my index name. And that's pretty much all we need there. Why is it? OK, there we go. Autocompletes. How many braces do I want here? Internet. Why is that unhappy? That should be everything. Or have I got too many there?
I think you've got one too many. Yep.
That's it. Yeah, my eyes are struggling. So Yeah, this is a fair criticism sometimes of using the Fluent syntax. Is, you know, this style is good for some people, not for others. I tend to use it. It's just a case that sometimes I mess up how many braces I need, and I have to let the compiler tell me about that. The other syntax for many of the other requests, as I say, is that we could actually use a more object-oriented approach where you actually create a new search request and then you set the properties on it, and then you just pass that into the client. That's a viable option. But for these helpers, I tend to prefer this style of configuration. So the other thing we're going to do, I'm going to chain a call here. I'm just trying to get these tabs a bit nicer. So the index here is index name, and then we can say, okay, what do we do if the server is struggling and it's returning something like a 49, which basically tells it, you know, I'm struggling under load here. If we were to get, sorry, I'm thinking about where my code's laid out, just try and make this a little easier to follow. So this is the request descriptor here, this R, and then these are the actual Fluent calls that we can make on there. So you can see we can just chain these together. So in this case, we say to the bulk helper, okay, when you're indexing the stuff, back off and retry a few times if the client asks you of it. We could also do, let's think, what else might we want to set on here? Oh, I suppose we could say, well, what is the back off time? And we can express that as this kind of string value here that represents 30 seconds, or we can add a time span in there if you prefer. We could also do max degree of parallelism. So I'm showing these. You don't always need to mess around with these, but one of the ideas here is if you're bulk indexing data, maybe we could do this stuff in parallel. So we can actually fire off 4 HTTP requests, each containing a certain number of pieces of data at the same time. We can just do that in parallel, because the underlying resource is, in this case, HTTP over TCP. So we could have multiple connections open to the server to help us get the data in more quickly. Generally, that might probably just want to be your CPU count, for example, but we default to the CPU count on your behalf if you don't set that.
I'm just wanting to make sure that I'm understanding. I'm familiar with bulk kind of as a concept with Elasticsearch, but bulk all itself is that an asynchronous? That is an asynchronous process, right? Because everything is running in parallel. So that is that why there isn't like a bulk all async, you know, option? Or I mean, could you be doing asynchronous stuff asynchronously so that you're, you know, I don't know, maybe if you're dealing with like terabytes or petabytes of data and you want to get that done in minutes, you can. Well, there is no way to do that, honestly, still. But yeah, is that why there's no bulk all async there?
Yeah, it's a good question. So what this helper does behind the scenes is it fires off multiple threads based on this value. So potentially 4 concurrent HTTP calls pushing out various chunks of data on your behalf. So in this case, what we're getting back from this is not actually a response, but this observable, which if you've used the observer pattern at all, is a way of sort of kind of decoupling the workload that's going on from the thing that then needs to deal with what happens when that's done. I am considering actually, you know, whether we add more traditional, certainly for some of the helpers, more traditional kind of async APIs here, because there's a new concept in .NET called async streams, which is potentially something we could use there, where we would actually read from the file asynchronously and we'd pass it into the bulk all asynchronously, and everything would be async all the way down. In this case, we're not doing that, but we're starting those threads for you. So if I just finish off this request, I can show you then how we use that. So let's say we put 1,000 items per request. So this is basically read 1,000 lines out of the file, chuck them into Elasticsearch. Once we have this bulk all observable, this is a thing that we could deal with, and we could create an observer that's watching this, and it says every time you successfully index some, you know, complete an index request, do this. If you get an error, do this. That can be a little bit painful. So what we have is a kind of helper on that, which is a method you can call called wait. And what we can say is, I want you to wait for a time span, let's say, let's allow this up to 10 minutes to complete. And then the other thing we can provide is a delegate as to what to do with the response. So every time behind the scenes, a bulk call response comes back from the server on whether it's on any of these 4 threads that might be running, here's what I want you to do with it. So in this case, we could say, well, let's just do console.writeLine data indexed. That'll do for now. What this does is essentially block. So waiting on that observer, that observable to complete its workload. So this isn't now async code because this is kicked off and then we're blocking and not in a thread blocking way necessarily, but the code cannot continue past this point until the index operation is completed. You may or may not want that behavior. You could push this off onto its own background sort of working thread that's doing your indexing for you, and then the rest of your application might continue. In this case, we're quite a sequential console app. So we're kind of saying, I want to start the bulk operation, and then I want to wait until that's done. Across that parallelism, across those requests that are each containing 1,000 items. So at this point, we should have something that runs. And this is the very dangerous comment, whether it does or doesn't run. Before we do anything else with the code, let's, do we want to, actually, we probably want to add the alias in here as the last operation. So what we can do is var alias response equals client.indices. Alias. And then in this case, we want to provide the, actually, we just want to put the alias over the index and alias, and hopefully I've got these the right way around. Cool. So this final operation here calls, again, Elasticsearch and says, okay, now this index has been created and we've pushed our data into it. We'll add an alias. So that means that from a consumer point of view, we can access that data through the alias. So that should be enough, and time is flying by. So that should be enough as a kind of minimal piece of code. So maybe we should run this. And while it's running, because if I've got the code right, at least, it's going to take a few minutes and then, or maybe a minute or so. I'll just drag this window over here. So I'm hoping we don't see any exceptions. Process should kick off. And okay, stuff's happening. So this console write line that's pushing this data index out is happening after every bulk request. And the reason that you saw sort of groups of those chunking in at once is because we were sort of saying you could actually do 4 concurrent bulk operations, each with 1,000 items. So that file's pretty large. You can see it's running now. It's going to churn through getting that data in. And I guess if there's any questions at that point, we can go to those. Otherwise, we can have a look at the data that we've got into Elasticsearch.
I don't think we have any questions in the chat. And if we do have questions, feel free to ask them in the comments. One thing I've looked at this, what is your, okay, well, I guess it's done now. I got distracted when it changed on me. I've noticed that even when trying to do bulk operations on like large data sets, and I'm not sure how large this data set is, but I mean, working with like millions of records, it can still be a bit of a process, or it can still take a little bit of time. Are there some ways that you can kind of increase the performance on that? Is there a way to maybe like bundle the data in a different way to maybe improve that processing time?
Yeah, it does depend on the type of data that you've got and the source that you're getting it from. So where I use this myself was we were reading off of a queue. And so the enumerable in that case was just data coming in off the queue. And when it reached 100, a bulk request went out. That worked quite nicely. Yes, different data sizes for different data sets might be necessary. So I've chosen arbitrary size of 1,000 there. I always recommend people experiment a little bit with those numbers. You might get better throughput actually by dropping down to 100 items per request, because obviously more items in a single request means one or less HTTP requests, but it means larger payloads, larger bodies going across the wire. So if you're dealing with a server that's maybe over a slow network, you might find actually it's better to send lots of small requests than many quite large ones. So that's something you can play around with. I think ingesting sort of raw data generally, I guess, is something you're usually doing up front when you're starting a project. And then normally you're kind of trying to keep pace with live data as it comes in. That's maybe a bit of a generalism, depending on what people are doing with it. But that was the use cases we had for it. And so we had a sort of an initial load process, which was this kind of basic console app world. And then we had a more sort of continuously running microservice process that would then, as I say, polar queue and index smaller chunks of data thereafter as they came in live within the system. So that's done. So I was going to probably go on to searching today, but maybe that's a good topic to kind of branch off it on the next stream. But it's probably important that we actually check that we have some data. So if I come into Kibana DevTools here, so I'm going to just do a cat indices here. And you can see we have this stock demo v1. Now you can see it's yellow. That's because I think it's trying to create a replica. And we only have a single node cluster here, so there's nowhere to put that replica. So don't worry about that. The main thing is that we have the data and it's not red. And we could do a search against that data directly using the search endpoint. If we just do that directly for a second, and you can see indeed we have some blocks of hits here in the data. And each of these has date, it has a symbol. The ones where we had the lookup for things like Microsoft, those would have the name in there as well. So you don't have to index the same fields in every document. It's kind of an open schema. But the thing that we should do is say demonstrate that alias. So here I'm accessing the index by its name directly, but we also created that alias, and you can see Kibana's picked up that alias name. And I can perform the same kind of search on the alias. And just to reiterate why I've done that now, is that if I were writing a consuming .NET application that's searching against this, and in the future we change how we want to store this data, maybe we can add fields and things all the time, that's kind of fine. But if we actually fundamentally wanted to change that, actually we don't store a raw date, maybe we store a time, a date offset from a different time, or we calculate, as you say, sort of runtime fields and things. We might want to eventually turn those into real fields of data. So maybe as you say, the delta between a high and low might be a field in the future we'd want. Rather than us kind of having to go and update every document in the existing index, it might be easier to create a new index, which is essentially the same as the old one, with that new field and that delta calculated by some script. But then our client applications, to take advantage of it, would have to use the, whatever we call that new index, so v2. With this alias, they wouldn't necessarily have to. So it doesn't mean that your application code will know what to do with those new fields. But assuming you're deserializing this into your own object type, consumers that don't know about those new fields should just work. They should be fine. You just won't have the new fields because there will be no property for them. But this gives us that ability to kind of switch out the underlying data, and you can kind of just think of it almost like a URL, I guess, to a web page. You can change where your website's hosted, and people that access your website don't need to update their URLs; they just use the same one because you've repointed it with DNS. Similar concept with an alias and an index, I guess. So I guess, given looking at the time, we had sort of an hour and a half of the session. Probably searching this stuff might be one for another stream. I don't know what you think, Jay, whether we want to kind of pick that up in a future session, and we can start to explore more of the different sort of parts of actually then querying data from Elasticsearch.
I think we could definitely get one scheduled, and even if we can, I know that I'll throw my face back on here now. There we go. Trying to avoid the amount of distractions on screen. I know that you often live stream yourself, and are you usually doing stuff like this? Or are you streaming about kind of the work that you're doing at Elastic?
Yeah, so it's definitely ad hoc streaming at the minute. I started with good intentions a few months ago, and I must admit it's kind of drifted off as lockdown in the UK eased and summer appeared quite early for us. Yes, it's something I want to continue doing, and it's kind of a combination of things I probably want to do. So I'm happy to do this kind of using Elasticsearch.net type stream, and maybe this is a scenario where we could do some basic searching and aggregations on it, but we could always build out a more real world application as well. That could be quite interesting. We do have a demo application that needs updating actually to the latest versions of sort of Elasticsearch and Elasticsearch.net, which is actually kind of a NuGet clone, and basically takes package data that exists in NuGet and creates a new UI over it that's searchable through Elasticsearch. So we could do some streams updating that. The other stuff I do like to stream is more what I'm working on. And I guess that's more niche for people to get involved with. But it's kind of fun for people, hopefully, where they can kind of see me probably trying and failing at a bunch of stuff, because that's what developers do. Like 90% of the day is have an idea, realize they can't implement it, and move on with their lives. But for example, I'm doing a bunch of work around optimizing the performance of the client for kind of vNext world. So what will be version 8. We're also doing some work around code generating the next client. So today, all of these, we haven't really seen many here, but these are kind of these response objects, the request objects. We handcraft those, and we have to do that based on the documentation and looking at the underlying, Elasticsearch code and API tests that we have. We have to kind of craft those objects by hand to try and fit them into a .NET-ism kind of world, try and make them sort of .NET synchronous. But that's a lot of work. And so in the next client, what we're hoping to do is actually do a lot of that code gen or through code gen, so it's automated, which gives me more time to focus on, how do I make these helpers better? Should we have a bulk call async that takes an iasync enumerable and is something you can just await on, pass in a cancellation token and say try this for up to 10 minutes, and then if it doesn't finish, move on. That might change the syntax a little bit. Other helpers, we've added things like point in time is a fairly new concept in Elasticsearch, which allows you to kind of take a snapshot, if you will, of data at a point in time for a short-lived point in time and then query over it consistently. There's some things we could do to add helpers to that. So that's the work I'd rather be doing than kind of manually keeping up with a very fast-paced API surface in Elasticsearch. And so there's certainly some streaming I can do on that kind of stuff. The one I did in the past was we did some experimentation around high performance serialization or deserialization actually of responses from Elasticsearch. So moving over to a newer .NET serializer, system text JSON, and looking at how we could maybe make that more optimal so that again, the client's as quick as possible. So lots of cool stuff I'm working on, and I will try and set up some more blocks of live streaming time, which will be up on my YouTube channel, which is just titled Code with Steve. You can find it off of my my Twitter bio, and I'll try and do some more stuff there as well, even if we don't do it on the mainstream.
And I definitely think that we can absolutely bring you back on for a Tuesday. Like I said, we're planning on doing these every Tuesday around the same time. So I'm sure we will definitely have a spot for you to jump in and continue with how to implement searching and maybe even some other things. I know there's a lot of pieces to building any simple project. You think you go in and it's like, all right, CRUD and I'm done. But even here we see just the C part of CRUD can take an hour if you have to break down how things are going. And I love the amount of thought that goes into this. I think that's something that we don't necessarily get away from, but Elasticsearch takes a lot of that thought away. So seeing it from the perspective of like, I could trust the process, let Elasticsearch grab everything, index it all. We often get too comfortable with that position. So being able to come back and say, all right, let me just make sure that this data is what I want it to be. And then also let me set it up so that Elastic has the best the best opportunity to make the right assumptions for me. Because that tends to be where I mess up with my stuff is I give it a date time field and it's like, it's in the wrong date time format. And then all of a sudden I've got a bunch of strings in an index and I'm like, this doesn't help me at all. But just being able to say, you know what, let me just verify that that's going to be set up as a date time, and then I'm off to the races from there.
Yeah, I think even, I mean, this demo data is, pretty clean. I think, full experience of working in the real world with Elasticsearch and just data in general is that data is rarely clean. We had stuff coming in on queues and we had all sorts of weird scenarios, and this stuff looks simple and it can be fairly simple if you know what you're dealing with. But as you get into real world situations, there's all sorts of things. Do you want to, as you say, handle those date formats differently for different requirements? Have you factored in time zones if your application's sort of global? And that stuff you tend to discover over time. And certainly this kind of AutoMap gets you started. You don't necessarily have to map these properties up front. One of the advantages, again, of this kind of alias approach is we could have created this V1 with the default mappings for all of the fields and just let Elasticsearch figure it out. And then as we were querying it, we might go, well, actually, we're never full text searching these symbols. So why create an inverted index of those values and go through the overhead of analyzing that data as it's indexed each time? And so then you could learn, okay, well, perhaps we don't need a text field. We just need a keyword. You create your V2 and you set up your mapping and you just create your V2 here. And then your work is re-indexing existing data. And again, that's something you could do server side, or you can do through the client or through helpers that we have for that kind of stuff. But certainly, as you say, it's amazing. Just this small thing. I did expect we'd be able to show more in the time, but as you start sort of explaining all this stuff, there's quite a lot of nuance, I think, dealing with any form of kind of data access. It starts off really simple in your head, but there's lots of edge cases to consider.
Definitely. And as we're wrapping up, feel free to ask questions about what Steve has put in there. Let us know in the comments what you'd like Steve to show us next, the next time he comes on the stream. I'm sure there's going to be plenty of opportunities for that. But yeah, just a quick reminder again, you can probably reach, Steve, as you mentioned, on Twitter. If you have questions regarding your own builds, your own, tests and deployments, feel free to do that by reaching out at discuss.elastic.co. We also have a Slack channel. I believe if you go to the Discuss page, it's like one of the top posts there where you can join the Slack channel and talk with us, in a more synchronous, asynchronous format. So that said, Steve, do you have anything else while we're waiting for any of the last questions to come in?
No, not really. Just a call out to the community again. I guess that if you're using Elasticsearch with .NET and you're running into either bugs or things that you think could be made easier for you, or edges of the API that aren't mapped in or aren't modeled necessarily 100% correctly, that does happen. Please do raise an issue. I can share. I'm sure you can put up a proper link to this actually, Jay. But if I just dive in here. So, we're up on GitHub, elastic/elasticsearch-net. That's the repo for both the low level and the high level client. So, you can raise an issue there. And we do have a discussions tab enabled there as well. So, if you have general, how do I do X questions, raise them there. And the final thing I would say on that is don't be worried about asking questions. People have asked questions. I've been here 6 months now. People have asked me questions about the client, and I'm like, yeah, I don't know. And I have to go through the code to figure it out, or I have to, create my own little sample application to explore that edge of the API. it's impossible to understand everything and know everything and retain it all. So, there aren't any daft questions, and I'm more than happy to try and figure it out on your behalf if it's related to what the client's doing.
I noticed someone in the chat had mentioned that they've been working with Elasticsearch from like 1.7 to 7.11. I think maybe a good final question is there anything in 7.13 that you're implementing or that you just implemented that people who have been working with Elasticsearch for a long time may not be aware of?
So I think probably the headline for us in 7.13, it was a bit of a delay from our side of actually getting it implemented into the high-level client, was supporting EQL, so the query language over events in Elasticsearch, which is kind of our inbuilt way of doing sort of event searching. And we didn't expose that to consumers through the library, but we have added that now in 7.13. So you can fire off an EQL query through the client and then get the data back. That was reasonably new. And as I say, just before that, point in time was a fairly new thing, and runtime fields. So both of those have been added in. Support for defining runtime fields at search time, and running scripts that will give you different calculated data based on the fields that you already have. Those are some cool things. And I think there's some really cool stuff. I've been watching 7.14. There's thousands of pieces of work being done by the team. It's incredible. And there's some stuff coming around helping you understand the cost of design decisions like the ones we've been talking about today. So you'll be able to get detail about the size of fields in terms of what the underlying data structures that we use to sort of index those, what those consume. And I think there's an API coming around understanding how often those fields are used and by what types of query. Those would be, I think, really useful for you, because today you do kind of have to kind of feel that stuff out through usage. But I think it'd be really useful for people, not really necessarily just through .NET. I think this will be more sort of a thing administrators are using to understand how they're modeling data. But you'll be able to explore, as I say, those uses and say, okay, this field's taking up a lot of storage. And this is something you might be able to see with something like the symbol field that we've just looked at. You can see, okay, it's a certain amount of storage here, but actually that's all in the inverted index, and I'm never querying that data in a kind of full text search fashion. So maybe based on those two pieces of information, you could then go in and make the decision to kind of reindex that data differently or model it differently in the future. So yeah, lots of cool stuff coming, I think.
And it wouldn't be a chat with me if I didn't talk about probably my favorite part of the Elastic Stack, and that's app search. How easy, or do you know how easy it is to take some of the same code that you've implemented here and apply that over to our app search, counterpart, where you're just dealing with more, this is strictly for the web. This is web data being presented on web with some of the built-in features.
Yeah, so that's a gap that we have today, and the client's team in general are kind of looking at supporting more than just Elasticsearch for our client. So, enterprise search, app search, those are other areas that I think scream out for a client supported by us, and it's something we're definitely looking at doing in the future. And again, it's another one of those reasons why if we can code gen some of the kind of the boilerplate for those, we can kind of bring those to market quicker for people, because today, the story there is a bit of a gap for people in the .NET sphere particularly.
All right, well, I'm gonna give people we have 5 more minutes left in the scheduled stream, but I'll give people a few more times. If you have some questions, you have some thoughts, comments, feel free to throw them in the chat. If you're not yet subscribed to the channel, be sure to do that. Hit subscribe. Like I said, we're going to be doing live streams hopefully every week, unless something happens, and we'll let you know from there. But we also have VODs for all of the other meetups that we do. We have several user groups all around the world, many different languages, a bunch of people in the community from Elastic, outside of Elastic, presenting all the fun stuff. just to kind of give you a quick idea of what we've got coming up in the next few weeks. Next week, it's going to be just me. Maybe I'll kick out the jams. We'll have some music going, and we'll be talking about Python, kind of very similar to what Steve's been doing here, but all in Python, and looking at some of the ways that we index data using all of the different Python frameworks that we have. And then after that, we're also going to be having a guest from outside Elastic coming in, showing how he lives and uses Elasticsearch to manage type 1 diabetes, which is like just mind-blowing. I've seen this. It's absolutely phenomenal, but it is super cool. But once again, Steve, thank you so much for being an amazing guest. Yes, Seth, I see you in the chat. There will be a Python stream next week. Make sure that you go to the community page and sign up for that. I don't want to give you the full link. I'll put the full link in the chat for that. But we did have one more question coming in really quick. And it's like, where can we get the documentation to search documents from a warm index? I think that's something that we can, we'll definitely get back to you on that. Because we'll have to scour through that documentation ourselves and get it to you. But make sure to have your notifications on. We'll comment back with an answer for that. Or if someone has the answer quickly, feel free to let Gumaluri know, and we'll definitely try to make sure he gets that answer. But yeah, Steve, thank you so much for joining us.
Pleasure. Thank you very much for having me.
Yeah, let everybody know one last time how they can get in touch with you if they'd like to.
Best way, if it's sort of more general and you just want to reach out, DMs are open on Twitter. So it's at Steve J. Gordon on Twitter there if you want to follow me and ping me when you have questions. If it's an issue, a bug, a feature request, or whatever for Elasticsearch.net, then it's best come to the issues here and file them. That way we can kind of triage them properly and make sure they get dealt with. I'm sort of relatively good at reading my Twitter DMs, and then I'll have a stint where I forget about them. So if it's a mission critical thing and it's related to the library, here's the place. And if it's more general, you want to give me your thoughts on it, then go through Twitter to begin with. Oh, I think maybe you're muted, Jay, or my speakers have just given up.
You're right. I am 100% muted. See, we still do it. I guess a good way to wrap it up. We did have one last question about 8.0. I don't think we have an exact release date for 8.0, but I know that we're working on that. You got any spoilers you want to show for, or you want to talk about for the .NET side of what 8.0 is going to have? Yeah,
so I think the main things are code gen, which is more of a kind of useful thing for us, I guess, to make sure that the APIs are consistent with what's actually in the product. And we can bring them out in our client quicker. Performance is something that I'm pretty keen on. I've been doing some work just this week, and I've been able to shave, it might not mean much to many people, but 512 bytes off of every request that goes out through the client, through our transport layer, was shaved off this morning in a test scenario that I was doing. So it's kind of that stuff. I basically want to make it easier to use the library. So docs, training materials, videos, that kind of stuff, updates to the API where there needs to be to make them, fit in with modern .NET and .NET 5, .NET 6 as those come along. And then certainly, performance. So that out of the box, you don't have to do anything. You just upgrade and you get a faster, less allocated experience. That means your resources are dealing with your code less than our code.
Awesome. All right. Well, again, you're going to have to look forward to that. I don't think we have a date yet, or at least not a date set, but I know there's a lot of chatter about what's happening in 8.0, so I'm excited as well. But that's going to do it for this week. Like I said, if you're not yet subscribed to the channel, we have plenty of live streams happening throughout the week. This is the US-ish, live user group that I'm working with. And Steve, thank you so much. I know you're in the UK, so it's a little bit later for you. So thank you for taking time in your midday, evening-ish time.
Evening, yeah. It's pretty much dinner time now, so it's nice time to wrap up.
Oh man, that's great. You can people who are also out there with them can grab a bite and go back and review the VOD for anything they may have learned. But yeah, that's going to do it for us this week. Again, next week it's going to be just me. We're throwing a party with Python, and we're going to be playing with some data and showing people how we index a bunch of different types of data all through the different values. So tune in for that next week. But until then, I've been Jay Miller. This has been the Elastic Live User Group, and take care, everyone.
Bye.